1997, number 88. So f of x, this is f of x. And let me make this bigger. That's going to be the integral from a to x, h of t dt. So, actually, h is above. I messed up. This is h. H of x. So, one of these functions down here is f. So, let's take a look. If you were to plug in a, the integral from a to a is going to be 0. So f of a should be 0. F of a is 0. F of a is not 0. F of a is not 0. F of a is not 0. F of a is 0. So the only candidates right now are a and e. So we can eliminate these three. All right, what's going to happen? So as I start to integrate further and further, it's going to get bigger and bigger all the way up to b. So the function is going to increase all the way to b. And both of these do that. And then I'm going to start subtracting because it's below and net area below subtracts. So it's going to decrease. And they both decrease, so I'm kind of stuck here. Now there's a way to do this visually that's kind of quick if you understand what's going on. But if you were to look at little chunks, you will notice I'm adding a bigger chunk as we go. So as we go, it's going to increase faster. It's going to look concave up, right? Because I'm adding more and more. This says I'm adding less and less. So I know it's going to be this one. If you don't see it that way, let me show you this. The derivative of f is going to be h of x. So this is f prime of x, right? So I'm using fundamental. If you don't know fundamental, it's going to hurt you on the test. If you take the derivative of an integral from a constant to x, all you do is plug x in. Now, if this were a function instead of x, like x squared, you still plug it in, but then you have to multiply by the derivative of that function. You need to know that. That's one of the fundamental theorems of calculus. Okay, so one of these down here is f. This is the derivative of f. But now check this out. See if this makes sense. On this interval, I claim f prime is increasing. If f prime is increasing, that means the second derivative is positive. If the second derivative is positive, that means f is concave up. So the one that has to match is the concave up in that region. This is concave down. This is concave up. It's got to be E. Okay, that's the other way to look at it that's a little more analytical. That's number 88.